All right, just up from my nap. It was very refreshing. Now I'm ready to talk about page 2. All right, page 2, example number 3. Here are the first two. It's going to take a little bit of space, and so let's see what we do here. We're multiplying two binomials that have radical expressions in them. And there's a couple like well-known strategies for multiplying pairs of binomials. One of them is FOIL. The other one is the box method. Yeah, let's do the box method, I think. I like that idea. Okay, so here I've got square root of 5 plus 3 times the square root of 2. Here I have 2 times the square root of 5 minus the square root of 2. You know how this works. Okay, up here I've got square root of 5 times 2 times the square root of 5. The square root of 5 times the square root of 5 is the square root of 25, which is also known as 5. 5 times 2 is 10. Okay. Square root of 5 times negative square root of 2 is just the negative square root of 10. Okay. Here, 3 times square root of 2 times 2 times the square root of 5. I do the 3 times the 2. It gives me 6. Square root of 2 times square root of 5 is square root of 10. Okay. I'm already noticing here, I've got like radicals. I'm going to be able to combine those. Okay. And then here, 3 times the square root of 2 times negative square root of 2 is 3 times, well, the square root of 2 times the square root of 2 is 2. So really what I've got is 3 times 2, but it's negative. So I get negative 6. All right. Put all this together, combine things that can be combined. I've got 6 times the square root of 10 and negative 1 times the square root of 10. If I combine those, I'm going to get 5 times the square root of 10. And then here in these other two boxes, that's just 10 plus negative 6, which is just 4. And I think that looks good. Circle it. Seal of approval. Okay. All right, so we'll go to the next one, but it's going to kind of work exactly the same as the one we just did. All right. Here's my box. Negative 10a times the square root of b plus 7b. And then a times the square root of b plus 2b. Okay. Take a close look at this. Negative 10a times a is negative 10a squared. And then square root of b times square root of b, that's b. Okay. Negative 10a times 2b, negative 20ab. And then there's this square root of b that can't be simplified. That's just that's it, right? Here, 7b times a is 7ab. There's another square root of b that doesn't simplify with anything. And then 7b times 2b is just 14b squared. Great. Time to combine like things. These are like terms. I'm going to combine those up. So negative 20ab and 7ab gives me negative 13 ab times the square root of b. These are not like terms, so I'm going to have, let's see, that's minus 10a squared b plus 14b squared. Sorry for the weird, like I just didn't have enough, like, you know, negative 13ab times the square root of b minus 10a squared b plus 14b squared. That's your final answer. Okay? All right. Okay, here's one more. It's a binomial times a trinomial, so I'm not even going to think about anything other than the box method here. It's a 2 by 3. like this. I'm looking at 2 times the square root of x plus the square root of y, okay, and then 6 minus, what am I looking at? Oh, square root of x and 8 times the square root of y. Yep. Sloppy. All right. Here we go. 2 times the square root of x times 6 is 12 times the square root of x. 2 times the square root of x times negative square root of x is negative 2x. Square root of x times square root of x is just x. 2 times the square root of x times 8 times the square root of y. Okay, I can multiply 2 times 8, which is going to be 16. And then since these have the same index, I can use that multiplication property of radicals, and I can combine those radicands under a single radical. So there's my term up there. Okay, 6 times the square root of y is just 6 times the square root of y. Square root of y times negative square root of x is negative square root of xy. Those are like radicals, sweet. And then here, square root of y times 8 times the square root of y is just 8y. Great. Put it all together. I only have these as like terms. So I'll start with that. 16 square root of xy, negative 1 square root of xy is 15 square root of xy. And then none of these are going to combine. So I'm just going to go 12 square root of x plus 6 square root of y plus 8y. And wait a minute. I almost missed this guy. Negative 2x minus 2x. So there's actually 5 terms in this. 15 times the square root of xy plus 12 times the square root of x plus 6 times the square root of y plus 8y minus 2x. Turn up. That's correct. Okay. Questions? You know what to do. Hit me up in office hours. Last example on this page. Simplify these expressions. This is example 4. We've got square root of 11 squared. Well, okay, look. Anything to the second power is that thing times itself. Square root of 11 times square root of 11 square root of 121 equals 11. That's kind of showing all of what's happening in this situation, right? The other thing you could have done or thought about is like, well, if that's a square root and that's a squared, then they kind of cancel out, right? So, multiple ways of thinking through why this answer makes sense, okay? Same thing here, right? I've got the 5th root of z to the 5th power. Now look, take the 5th root of z, multiply it by itself 5 times. What's going to happen? These are going to cancel, right? This exponent and that index cancel each other out. Or, I kind of like this. What's the exponent way of representing this radical expression? Well, the 5th root of z is also low-key z to the 1/5, right? But if you have that to the 5th power, what's the power rule for exponents? If I've got a power to a power, an exponent to an exponent, you multiply them. What's 1/5 times 5? You set it 1. So z to the 1 or low-key, just z, okay? Again, multiple ways of thinking about what's happening when you've got situations like these, okay? Now the last one. We've done all the talk, like we've done this one, we've done this one. Maybe you'll believe me if I just say, if I've got the 3rd root of pq to the 3rd power, what happened here, what happened here? Cancel, cancel. 3rd root, 3rd power, you just get that radicand pq. Right. See you later for page 3.